And now in this lecture we find out the area of a square. In the drawing we have a right triangle ABC, and we know that the length of side AB of the right triangle ABC equals to 5 units, side BC equals to 12 units in its length. This is angle ABC, that is a right angle. Inside this right triangle ABC we have this square DEFG, and our mission is to find out the area of this square. Okay, so first of all we find out the length of the hypotenuse AC of the right triangle ABC. According to the Pythagoras theorem, of course, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and it must be equal to AB squared plus BC squared. Repeat again, in the right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. So AC squared, that is the square of the hypotenuse, equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So in conclusion, we found out actually that AC squared equals to 25 plus 144, that is actually 169. So AC squared equals to 169. We take the order out of this equation, and finally we get that AC equals to the square root of 169, that is 13. So AC equals to 13 units in its length, and what's it down in the drawing itself, that AC equals to 13 units. Is equals to 14 units in its length. We have the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. We can implement the rule in our drawing. One because we have line segment AC. Line segment AC is one side of the right triangle ABC, therefore it is absolutely a straight line. So we focus on the lower side of the straight line AC at point D. Here the sum of the angles must be equal to 180 degrees according to the order that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is a right angle plus the missing angle. In total the sum of those two angles must be equal to 180 degrees according to the order that I mentioned. Therefore the missing angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the lower side of the straight line AC at point D to 180 degrees, the missing angle must be equal to 90 degrees. Likewise, we focus on the lower side of this straight line AC at point E. Here, the sum of the angles must be equal to 180 degrees, according to the rule that I mentioned. So, which angles we have at the lower side of AC at point E? We have this angle that is the right angle plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. So the missing angle must be equal to 90 degrees in its size. In the next step, we define the length of this 97 BG as x. So what is the length of line segment GC? From the drawing it is very easy to see that GC equals to BC minus BG again. BC minus BG equals to GC. So GC equals to BC, that is 12, minus GC, that is x. So in total, GC equals to 12 minus x. Let's write it down. Let's say this segment GC equals to 12 minus x units in Snell. In the next step, we define this angle as alpha. So angle ACB, this is angle ACB, that is equals to alpha according to our definition. And we focus on this right triangle, triangle ABC, the big right triangle, triangle ABC. In the big right triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees. That is the sum of the angles in any triangle. Therefore the missing angle must be equal to 90 degrees minus alpha. We define 90 degrees minus alpha as beta. And therefore the missing angle must be equal to beta. Here we have the equation that 90 degrees minus alpha equals to beta. We will add to this equation alpha and then we subtract beta simultaneously, and we get that 90 degrees minus beta equals to alpha. So in the next step, we focus on this right triangle, triangle ADF. In the right triangle ADF, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha here, 90 degrees minus beta equals to alpha, therefore the missing angle equals to alpha. Likewise, we focus on this right triangle, triangle EGC. The right triangle EGC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. Here, 90 degrees minus alpha equals to beta. Therefore, the missing angle must be equal to beta. Line segment BC. This is line segment BC. Line segment BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line BC at point G here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of AC at point G? We have this angle that is beta, this angle that is 90 degrees, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on the upper side of the straight line is equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees minus beta. But again, the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha here, 90 degrees minus beta equals to alpha. Therefore, the missing angle equals to alpha. So in the right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. but 90 degrees minus alpha equals to beta, therefore the missing angle equals to beta. So in the drawing we have in total 4 right angles, 1, 2, 3, and the right big triangle, triangle ABC. Actually, all the 3 angles, each right angle has 3 angles that are alpha, beta, and 90 degrees. So all the right angles, the angles in all the right angles in all 4 right angles are correspondingly equal to each other, because each right angles have the 3 angles alpha, beta, and 90 degrees. So, for example, the big right triangle ABC is similar to this small right triangle FBG because they have actually the same 3 angles, alpha, beta, and 90 degrees. So I write it down. The big right triangle ABC is similar, this is the sign of similar, to the small right triangle, triangle FBG, according to angle, similarity rule. And for the fact that those 2 right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that BG, but before that, we define the length of one side of this square DEFG as L. So DE equals to L according to our definition, and therefore all the other 3 sides must be also equal to L in their lengths. Why? Because of the fact that all the sides in any square are equal to each other. So the right big triangle ABC is similar to the right small triangle FBG, therefore according to angle similarity rule, and therefore the following relationship exists between their sides. Side BG over side FG in the right triangle FBG is equal to side BC over side AC in the right triangle ABC. Repeat again. BC over BG over FG equals to BC over AC. So BG equals to X and FG equals to L, and it is equals to BC, that is 12, over AC, that is 13. In conclusion, found out that according to equation 1, X over L equals to 12 over 13. Here we'll multiply this equation 1 by L, and finally we get that according to equation 1, X equals to 12L over 13. So according to equation 1, X equals to 12L over 13. Likewise, the big right triangle ABC is similar to this right triangle, triangle EGC, according to angle similarity rule. So I write it down. The big right triangle ABC is similar to the right small triangle EGC, according to angle similarity rule, and therefore the following relationship exists between the 2 similar triangles. GC over EG in the right triangle EGC is equals to AC over AB in the right triangle, the right big triangle, triangle ABC. repeat again, from it to equation 2, GC over EG equals to AC over AB. GC is 12 minus X over EG. EG is L. And it is equals to AC, that is 13, over AB, that is 5. In following order, according to this equation 2, 12 minus X over L equals to 13 over 5. Here we will cross multiply this equation 2, and we get that according to this equation 2, 5 times 12 minus X equals to 13L. We'll open the brackets on this side of this equation 2, and finally we get that 5 times 12 is 60, 5 times minus x is minus 5x, and it is equal to 13L. Here we'll add 5x to this equation 2, and finally we get that 60 equals to 5x plus 13L. Here we'll subtract 13L from this equation 2, and you get that according to equation 2, $60 minus 13L equals to 5x. And again, I shall find out that according to equation 2, $60 minus 13L equals to 5x. In the next step, we substitute x in this equation 2 by the value of x that we found in equation 1. According to equation 1, x equals to 12L over 13. Therefore, we substitute x in this equation 2 by 12L over 13. We do it now, we get that according to equation 2, $60 minus 14L equals to 5x, and according to equation 1, x equals to 12L over 13. So we found out that according to equation 2, 60 minus 14L equals to 5 times 12L over 13. So 60 minus 14L equals to 5 times 12L is 60L over 13. When you found out that 60 minus 14L equals to 60L over 13, here we'll multiply this equation 2 by 13. And you get that according to this equation 2, 60 minus 14 is 780. 13 times 14L is minus 169L, and it is equals to 60L. Here we'll add 169L to this equation 2, and you get that according to equation 2, $780 equals to 60L plus 169L equals to 229L. Here we divide this equation 2 by 229, and finally we get that L equals to 780 over 229. So 780 over 229 equals to 3.40611. N equals to 3.40611 units. That is to say, the length of one side of this square DEFG, the length L, is equal to 3.40611, and the area of a square equals to the length of one side squared. So the area of square DEFG will be equal to the length of one side squared. The length of one side is L, therefore the length of one side square is L squared. And you just right now found out that L equals to 3.40611. Therefore L square is 3.40611 squared, and 3.40611 squared is equals to 11.6016 square units. In conclusion, we found out that the area that we are looking for, that is actually the area of square DEFG, is equals to 11.6016 square units. And that is the answer to the question. Repeat again. The area of this square DEFG is equals to 11.6016 square units. So in the next step, I will summarize the lecture. So in the drawing, we have the right triangle ABC. Inside the right triangle ABC, we have this square DEFG, and our mission is to find out the area of this square DEFG. In addition, we know that the length of side AB is 5 units, side BC equals to 12 units in its length, and this is angle ABC, that is the right angle. Again, our mission is to find out the area of this square DEFG. So first of all, we implemented the Pythagoras theorem on the right triangle ABC. On the right triangle ABC, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In the right triangle ABC, the hypotenuse is AC, therefore the square of the hypotenuse is AC squared. So AC squared must be equal to AB squared plus BC squared. AC squared, that is the square of the hypotenuse, equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So if we found out that AC squared equals to 25 plus 144, that is 169. So AC squared equals to 169. We took root out of this equation and finally found out that AC equals to the square root of 169, that is 13. So the length of the hypotenuse AC is 13. In the next step, I presented to you the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. We can implement the rule in our drawing. In our drawing, we have line segment AC. Line segment AC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if you focus on the lower side of this straight line AC at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle. In total it must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees. Likewise, we have, if you focus on the lower side of this straight line AC at point E, here the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of AC at point E? We have this angle that is 90 degrees plus this missing angle. In total must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees. In the next step, we defined the length of this line segment line segment BG is X, and therefore GC equals to BC minus BG. Again, BC minus BG equals to GC. So GC equals to BC, that is 12, minus BG, that is X. So in total, GC equals to 12 minus X. Okay, then we define the length of one side of this square DEFG as L. Therefore, DE equals to L, EG equals to L, DF equals to L, and FG also equals to L. Because of the fact that all the sides of any square are equal to each other. In the next step, we define this angle as alpha. So in the right triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. So the missing angle must be equal to 90 degrees minus alpha. But we define 90 degrees minus alpha as beta here, and therefore the missing angle must be equal to beta. So we have the equation that 90 degrees minus alpha equals to beta. If we add to this equation alpha and then we subtract beta simultaneously, we get that 90 degrees minus beta equals to alpha. So in the right triangle ADF, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle must be equal to alpha. Likewise, in the right triangle EGC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, and therefore the missing angle must be equal to beta. Line segment BC is one side of the straight line, is one side of the right triangle ABC, therefore it is absolutely straight line. So BC is a straight line. We'll focus on the upper side of the straight line BC at point G. Here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on the upper side of a straight line is equal to 180 degrees. So which angles we have at the upper side of BC at point G? We have this angle that is beta, plus this angle that is equal to 90 degrees in size, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line BC at point G. So the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, and therefore the missing angle must be equal to alpha. So in the right small triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle must be equal to beta. So actually found out that all the four right triangles that we have in the drawing, we have in total 4 right triangles, 1, 2, 3, and the fourth right triangle is the right big triangle, triangle ABC. All the 4 right triangles are similar to each other according to angle, similar to rule. Each right triangle has the 3 angles of alpha, beta, and 90 degrees. Therefore, all those 4 right triangles are similar to each other according to angle, similar to rule. For example, the right big triangle ABC is similar to this right small triangle, triangle FBG. Why? Because they have exactly the same 3 right triangles, alpha, beta, and 90 degrees. So write down that the right triangle ABC is similar to the right small triangle, triangle FBG according to angle similar to, and therefore the following relationship exists between their sides. Side BG over side FG in the right triangle FBG is equals to side BC over side AC in the right triangle ABC. Repeat again. BG over FG equals to BC over AC. BG is X, FG is L, BC is 12 and AC is 13. In conclusion, found out that according to this equation, equation 1, x over L equals to 12 over 13. Here we multiply this equation by L and finally found out that x equals to 12L over 13. Okay, according to equation 1, x equals to 12L over 13. Likewise, the right big triangle ABC is similar to this right small triangle, triangle EGC. According to angle, similar rule. Repeat again, the right big triangle ABC is similar, this is the sign of similar, to the right small triangle, triangle EGC. According to angle, similar rule. So, and therefore, the following relationship exists between those two similar triangles. GC over EG in the right triangle EGC is equals to AC over AB in the right triangle ABC. Repeat again, GC over EG equals to AC over AB. GC is 12 minus x, EG is L, AC is 13, and AB is 5. So in conclusion, found out that according to equation 2, this equation 2, 12 minus x over L equals to 13 over 5. Here we cross multiply this equation 2, and finally found out that 5 times 12 minus x equals to 13L. Here we open the brackets on this end of this equation 2, and finally found out that 5 times 12 is 60. So 60 minus 5x equals to 13L. Here we added 5x to this equation 2, and finally found out that 60 equals to 5x plus 13L. Here we subtracted 13L from this equation 2, and finally found out actually that 60 minus 13L equals to 5x according to this equation 2. In the next step, we substituted x in this equation 2, but the value that we found for x in this equation 1. We found out that according to this equation 1, x equals to 12L over 13. Therefore, we can substitute x in this equation 2 by 12L over 13. We did it and found out actually that 60 minus 13L equals to 5x, and x is 12L over 13. So therefore, in conclusion, found out that 60 minus 13L equals to 5 times 12L over 13. 5 times 12L is 60L, so in total this expression equals to 60L over 13, and it is equals to 60 minus 14L. In conclusion, found out that according to this equation 2, 60 minus 14L equals to 60L over 13. Here we multiply this equation 2 by 13, and finally found out that 13 times 60 is 780. So 780 and 13 times minus 14L equals to minus 169L. So in conclusion, found out that 780 minus 169L equals to 60L. Here we added 169L to this equation 2, and finally found out that 780 equals to 60L plus 169L equals to 229L. In conclusion, found out that according to equation 2, 780 equals to 229L. Here we divided this equation 2 by 229L, and finally found out that L equals to 780 over 229. 780 over 229 equals to 3.40611 units. So, in conclusion, found out that the length of one side of this square DEFG L, the length L is equals to 3.40611 units. What is the area of this square DEFG? That is the area that we are looking for in this question. The area equals to the length of one side squared. This is again the area of square DEFG, that is the area that we are looking for, equals to the area of the length of one side squared. The length of one side is L, and therefore the length of one side square is L squared. L equals to 3.40611, and therefore L squared equals to 3.40611 square. And 3.40611 square equals to 11.6 In conclusion, found out that the area of this square DEFG is equals to 11.6016 square units. Okay, thank you very much.